Ooh, big. Okay. I don't understand. All right. So we have been through a lot here. We've been through some population ecology. We got to the demographics transition. Oh, we're going to teach you wait. It's a mess. No worries. Which brings us kicking and screaming into chapter 6. Maybe. All right. No, we just kind of got to the top of the page. So here we are at the top of the page. With something called the tragedy of the commons. Remember, I said I wanted you to have the human population growth curve in the back of your mind as we go through all these environmental problems we're about to go through, because environmental problems are kind of a logical consequence of there being this many of us, right? Humans live a certain way. If there's 7 billion of us, there's going to be some pressure on ecosystems. This is the second thing I want in the back of your mind as we go through it. It's called the tragedy of the commons, and it's kind of almost like what do you call like those stories that have morals or like lessons to them? Kind of like a folk tale or a fable or whatever, but they're like an ecology version of one. Kind of. It's something about human nature. So the story is this: that there's this this village in let's call it Scotland, in like ancient Scotland, and all the people who live in the village are shepherds. They all raise sheep, right? And the town has this expanse of grassland that belongs to the town, right? Not any one person, it belongs to the town. And the elders or government or whatever says, okay, from here on out, this land is the commons. And all of you shepherds can bring your sheep here and graze them, because sheep eat grass, right? And you can graze your animals, and there's enough for all of your existing herds of sheep to be able to graze comfortably without overtaxing grass. And we all live happily ever after. And everybody said, yay. And then what happened? What happens next? Knowing that this is a story about human nature.
More sheep.
Where do they get more sheep? Why didn't they have more sheep before? Because they knew they had a limited amount of grassland that was theirs. They had a certain amount of sheep, and they stuck to that amount of sheep and made their living off of that. As soon as they knew the grass was unlimited, what they started doing? Well, shoot, there's more grass. It means I can have more sheep, make more money, get more stuff. So everybody starts getting more sheep, accelerated by them looking at each other going, well, he's getting his, so I'm gonna get mine, right? Like everybody starts, and so suddenly it's like a sheep arms race. Place is covered with sheep. The whole field gets overgrazed, and what happens when grass gets overgrazed is the photosynthesizing part of the grass gets eaten down so far that all the plants die and it turns into a desert. Called desertification, we'll get there. Yeah, so the tragedy of the commons, that's the story. And basically the moral of the story is this. This is a story that's meant to tell you that when humans have access to a resource that has any value at all, when everybody can use it, but no one is responsible for regulating it, preserving it, it gets destroyed. That's what we do. It sounds kind of grim. And some of you are thinking, no, not everybody's like that. Come on. I only need one example to convince you, I think. Because I saw Logan on Halloween. You know what I'm talking about?
Yeah.
That one house where they're not going to be home on Halloween, so they put out the big bucket of candy with the sign that says, please only take 2 buckets of candy? You know that house, right? And there's like a line, and you watch the people in line, and that first kid's a good kid, so he's got his, pillowcase, and he grabs his 2 pieces of candy. And the next kid, his parents with him, so he grabs his 2 pieces of candy. Next kid kind of looks around, takes a nice scoopful. Next kid takes his double handful, and then Logan's there. He's like, dude, it's half gone. Everybody else, the next kid's gonna do it if I don't. And he grabs it and just dumps it in the pillowcase, right? That's it. I know you didn't do that one. I did that. Every once in a while. I make a game of picking the kid, right? Every once in a while. There wasn't really anybody good in here, but every once in a while I pick a kid and they're like, you saw me? Like they actually totally did that. Anyway, at this time. Yeah, it's like, okay, that's totally gonna happen if that's how you deal with your Halloween candy. Now imagine that same bucket filled with $100 bills. And it says, please only take $200. And we're talking about adults coming up to the bucket. What happens? Oh, instantly gone, right? Think of the Pacific Ocean as a bucket full of $100 bills. Think of the oil reserves under the ground as buckets full of $100 bills, right? If it's worth something and you can't stop people from taking as much as they want, it's going to go away fast. So that's thing 2. Thing 1 is there's a whole buttload of people covering this planet. And thing 2 is we are kind of wired to take as much as we can of something. And it's no accident. It's how we evolved. We evolved as hunter-gatherers, right? To where you don't know when the next time you're going to get stuff is. You killed a deer, great. It might be a month and a half before you kill another deer. You're going to eat as much of that deer as you can so that nobody else can get it and so that you store the excess calories as fat because you'll be able to live on that fat later, right? That's how we're wired. And that's part of why we act like that. So really, those 2 things go a long way to explaining what we're about to go through. All right. Next, resources. You could teach this to me, couldn't you? There are 2 types of resources. The first type of resource is a non-renewable resource. Non-renewable resources are resources such as, what are they? Come on. Oh. Yeah. Coal, oil, natural, like the holy trinity of fossil fuels. And yeah, when they're gone, they're gone. Absolutely. That is definitely a non-renewable resource. They took millions, billions of years to form. That's a lot of ferns dying and their carbon getting buried under the ground and eventually converting into this burnable, high energy release type stuff. And we've built a lot of our society around using those for energy. So there's a shift going on, right? As we start to really realize that, yeah, we're coming up on that turning point of those aren't going to be available forever. So we have to look into things like solar and all that other stuff. But when we say there's renewable and non-renewable, it's a little bit optimistic about the renewable. We tend to be a little bit optimistic because we include in renewable resources, we include things like wood and water. And while it's true that technically these are renewable resources, as you're going to see here, the kind of timber you can really build good stuff with, well, we've cleared an awful lot of that off the planet. Good old growth hardwood, not real replaceable. Those trees take hundreds of years to get to full size. Water, well, the kind we're interested in for keeping us alive is fresh water, and that is a finite supply. We are changing the distribution of water on this planet from fresh to salt water quite quickly, from clean to polluted water. Wind and air probably aren't going away, so that's nice. Wind and sun probably aren't going away, at least not in our lifetimes. By the way, don't ever tell a little kid that the sun's going to go away someday. No, that's not good. My son asks me like deep questions, and then I feel like I have to answer, and then I always regret it. Like if I go too far, like, oh, sorry, dude. Anyway. Yeah, so we have these resources that some of which we think of as renewable that maybe aren't as renewable as we think. So here we go. Here comes the depressing part, the laundry list. So let's start with water. On purpose, because a lot of ecologists do sort of think of this as the big first major crisis we'll have, beyond, wildfires and stuff like that come with climate change. Fresh water depletion is an issue that's starting to happen in a lot of places already, only going to get worse. Basically, the first part of this is groundwater. We talked about how groundwater is this sort of misunderstood thing that it's not like a real underground river, it's more like a slushy. And when you pull it too fast from the ground, it creates this cone of dry earth. And in places where there's not a lot of rainfall, but there is a lot of groundwater, the American West, for example, there's a lot of farming that happens out there that relies completely on groundwater. And so those places, as they get to big industrial-sized farms, giving water to cattle and watering crops, they are pulling that water out of the big underground aquifer out there under like Oklahoma and New Mexico. It's called the Ogallala Aquifer. It's been drawn down like crazy. It's in full slushy mode with the cone. And so that kind of stuff flows at about 1 inch or 2 inches per year. And it's hundreds of years to regenerate back to where it was. So that's a problem. Then we have the sort of double whammy of clearing a lot of the trees from the Earth's surface and farming in ways that aren't sustainable. That tragedy of the commons part where the overgrazing happens, that really does happen. And turns places essentially into deserts because it eliminates the soil's ability to hold water. And now you're decreasing the groundwater's ability to recharge. So this is a rough one. This is why large corporations are buying up water rights like there's no tomorrow, because if they own it, they stand to make a profit from it. And yeah, okay, you should probably take shorter showers and not run the water the whole time you're brushing your teeth and all that, but really, realistically, you yourself, your personal habits are not the problem. At least in this country, we're looking at about 75% of the freshwater use is agricultural. Problem is we have a lot of people to feed. And are kind of stuck in ways of farming that aren't real water efficient. Guys, there's ways to do this that are more water efficient. Not saying this would solve the whole problem, but most big agricultural fields that are irrigated with something that looks like this. This looks familiar? You ever in a plane? I mean, not recently probably, but if you're ever in a plane and you look down and you see big circles, fields that look like perfect circles, it's because of this thing. I don't remember what it's called, but it's basically a giant rotating arm on wheels, right? And it's pinned to the middle of the field. And as the water comes through and sprays down through these things, the thing rotates at the hub, the center of the field, in a circle, right? Look how high off the ground those jets are. And the sun's beating down on this thing in hot weather. Where does most of that water go, do you think? Straight into the atmosphere. Yeah, you lose a ton of it, over half in some cases. So drip irrigation is a different way to irrigate, where instead of having something above, suspended above, moving around, you just run little tubes all up and down your rows, and you have the water steadily dripping out under the cover of the crops so that it's shaded, and it kind of bleeds into the soil gradually and is a much more efficient way. You lose almost zero of that water in that way. So drip irrigation, wetlands, one of those ecosystems that humans tend to clear, both because they have lots of mosquitoes and because you can't build hotels on them. Well, they also turn out to be things that recharge groundwater at a pretty high rate. They're water purifiers. When water comes into them, whether it's rainfall or flooding. In fact, there's estimates that if even half of the original wetlands around New Orleans had been there when Katrina hit, which of course flooded and caused mass destruction, those floodwaters would have been absorbed very easily by even half of the original wetlands. So protecting wetlands is a potential solution. I actually have a video that goes into more detail here. We'll see how much time we have for it. But real interesting problem that, it's going to be in our lifetimes that we have to deal with it and solve it. If you're thinking, hey, there's all that ocean water, what about that? Can't we just make that into fresh water? Well, sure, but that costs money and energy. And so we're into something like water where humans have to have it to survive, and it starts to cost money, then we run into some real problems with inequality and stuff like that, right? Anyway, all right, ozone holes. This is a fun one, actually. I told you I would do my best to inject a little bit of sunshine into the gloom here. This is one of those, believe it or not. Ozone is a gas. It's a form of oxygen, right? O3 instead of O2. Which happens when oxygen gets ionized. And turns out there's this layer of it in our atmosphere. What does that layer do for us? What service does the ozone layer provide for us? Correct. A portion of the sun's radiation is ultraviolet, and the ozone layer blocks some of that UV light enough that you don't get as sunburned as you could, so that living things don't get as penetrated by UV light, which is very good at getting through cell membranes and messing up DNA, hence skin cancer risks, right? So what ozone there is protects us from that UV light. And it turns out that there's this chemical called chlorofluorocarbons, and there's some other ozone-depleting chemicals as well, that knock ozone apart. And that happened enough that there started to be, and still are, holes in the ozone layer at the north and south polar regions that open every summer and close every winter. A lot of airflow dynamic stuff you have to know to understand how this works, but basically, in the winter, there's this polar vortex thing that happens at the North and South Pole where all the CFCs and ozone get concentrated together, and that's where it gets knocked apart, the ozone gets broken. Then in the summer, when it all spreads out over the planet again, that's when these holes open up. And so, yeah, you notice, it's thinner at the poles for sure. And when the hole's there, I can tell you, I mentioned that I was in Antarctica. We were going out in boats every day looking for insects. There's like the size of a toddler, a tub of sunscreen by the door when we would go outside, and you would basically hit a huge pump and just slather yourself in sunscreen because you would be burned very quickly out there because of the ozone holes. Yeah, so increased UV light is not good for living things, not just us, but anything. In fact, in Antarctica, my roommate, we all had roommates and bunk beds, it was like college. He was a big blonde kind of surfer dude from University of Arizona named Tad. It's hilarious. He was a botanist. He and his friend, or coworker, Wally, who was a big burly dude, had these tiny little showers, and every morning I would hear Wally swearing in the shower because he was so big that he could barely get around, and so he'd drop stuff and you hear him like, anyway. These guys were botanists studying the effects of the ozone hole on plants, and so they had a plot of like plants in back of the station, and every day they would take their data, and every night they would crunch their data together and do work until like midnight. He was an odd dude, Ted. He had a pet rock named Mr. Stripey that he kept by his bed. Every once in a while, he'd just be like, "Hey, Luke, do you miss him?" "Miss who?" "Mr. Stripey. I miss him." Anyway, one day, Tad came home, came back to the room, just angry. Just, you could tell. I think he'd had a couple and he was not happy. He's like, look, it is over. I'm done. Screwed, man. What's going on, Ted? Calm down. It's over. I can't take any more data. We got 3 more weeks here. It's not worth anything. Can't take any more data. Come to find out, really bad news for Tad. Really good news for the planet. That year was the first year the ozone holes closed early. And it turns out now, this is 2020. So of course, or it was 2020. So of course, this past year, they got bigger again. But since 2005, from then on, the ozone holes were shrinking. I'm not sure what's going on now. But basically, once CFCs got banned, we are starting to see the effects of that, where the holes appear to be steadily shrinking. Again, 2020 was weird, but 2020. So kind of a happy thing there. But yeah, they were not happy because basically they had written this grant and gotten all this money to go down and study this, and suddenly they were stuck on station for 2 or 3 weeks with no data to take because the ozone holes had closed, right? Commonly confused. Ozone depletion, commonly confused with climate change, not remotely the same thing. Yes, they both have to do with gases. But one of those, ozone depletion, has to do with protecting us from UV rays. The other one has to do with too much of a particular gas, right? Holding too much heat in. Sam, you have a question?
Can you guys measure and figure out